Welcome back. In this video, we're going to solve word problems that are rate times time equals distance and solution problems. You may recall for those problems in the past we have used charts. I have the charts again. You may use the charts to help you find your two equations, or if you can find the equations without using the charts, that is fine as well. But our process is going to stay the same. We're trying to solve word problems that have two unknowns, so we'll use two unique independent equations to help us do that, and we can use the charts to help us find those equations, or as I said, you can do those. You can set up the equations on your own. So again, our instructions are the same. Identify your variables, write the two equations using those variables, and then solve the system algebraically and, of course, answer the question. So in our first scenario, Paul and Clem want to bike the 188 miles from Milwaukee to Rhinelander relay style. Paul bikes 20 miles per hour and Clem bikes 16 miles per hour. If they want to bike the total distance in exactly 10 hours, how many hours does each have to bike at a given rate? So we know that this is rate times time equals distance. So we can set up our chart, and we know that we multiply across, and generally we add down. And the two heroes in our problem, our two subjects, are Paul and Clem. So we've got Paul, and we have Clem, and we'll use the total row here as well, just like we saw in Microsoft Excel. And we've got a rate for Paul. Paul's rate is 20 miles per hour. Clem's rate is 16. Now, we don't know how long each of them bike. In fact, that's our question. But we do know the total time is going to be 10. So let's let x equal the time that Paul bikes, the quantity of time he's biking, and we'll let y be the quantity of time that Clem bikes. We know the entire trip is 188 miles. So in our chart, multiplying across, our distance for Paul will be 20x, our distance for Clem will be 16y, and our two equations are sitting right here in these two columns, in our time column and our distance column. So our two equations, the first one, x plus y equals 10. We have a time equation and we have a distance equation. That is 20x plus 16y equals 188. So you can use the substitution method if you wish. It's easy to solve for x or y. In terms of the other variable, I, of course, am going to use linear equation, and I'm going to multiply my top equation, my time equation, by negative 16. So I get negative 16x minus 16y equals negative 160. And I can add my two equations together. And when I do that, the y's will drop out. The elimination method works perfectly here. And we get 4x equals 28. We divide by 4, and we find out x equals 7. So x, of course, is Paul's time, so 7 hours is Paul's biking time. And if they were going to bike a total of 10 hours, okay, x is 7, so we can eyeball here that y must be 3. So y equals 3 hours. So Paul totally gets the better end of the deal here. He gets a lot more time on the bike. Clem's going to be sitting around doing a whole lot of nothing for most of this trip. And And he doesn't have to bike very much, okay? Because Clem, actually, if you want to see that, Clem is only going to bike 48 miles of this trip. Paul's going to do the rest of it, which is a lot more fun, right? Because Clem bikes 16 miles an hour for 3 hours. He's going to bike a total of 48 miles. And Paul, 20 times 7, he's going to bike for, what, the 140 miles. So Paul totally has the better end of the deal here. Let's go on to our next word problem. Halloween, the mad scientist, wants to create 15 liters of a 40% goblin's blood witch's brew. He currently has solutions of 20% goblin's blood and 80% goblin's blood. How many liters of each must Hal mix to create his desired brew? Okay, so we have 2 different brews here. We actually have 3 different brews. We have an 80% witch's blood brew. We have a 20% brew, but our goal is to get a 40% brew. So that's our end mix. And like we've seen in the past here, we have a quantity of witch's brew that we'd like that is a certain percent blood. This is kind of gruesome, but it is a Halloween problem. Well, we want our total quantity. We want to create a 40% witch's brew here. So we know that that's going to be 0.4. That's 40%. And the total quantity is going to be 15 liters. Well, we don't know how many liters of each must he mix of the 80 and the 20%. So we'll make the 80% the quantity of X, or the quantity. X will be the quantity at 80%, pardon me, and Y will be the quantity at 20%. And of course, 80% is going to be 0.8, and that's 0.2. So we have, if we multiply across, like we've done before, we know that this is going to be 0.8x, that's going to be 0.2y, and this is going to be 0.4 times 15. And we have, sitting right here, our 2 equations. We have a quantity equation and essentially a total equation. Before we had a quantity equation and a value equation. That's really what this is. Okay? So, let's write our 2 equations. We have x plus y equals 15, and we have 0.8x plus 0.2y equals 0.4 times 15. So I am going to multiply the entire second equation. I'm going to multiply that by 10. Some of you may have already done that right in the table automatically. But we'll go ahead and make that 8x plus 2y equals, well, 4 times 15. Hopefully you'll see that's 60 right away. And again, you can do the substitution method. I would solve the top equation for x or y. I rarely do that when I've got things in standard form. I'm just going to go ahead and multiply the top equation now, my quantity equation, by, well, negative 2 would be really easy. So I get negative 2x minus 2y equals negative 30. So my y's will be eliminated. They'll drop out. I get 6x equals 30. I divide both sides by 6, and I get x equals 5. So now I know that's 5 liters. 5 liters at 80%. And since I knew x plus y was equal to 15. I know y is equal to 10 liters at 20%. So I've answered the question. He needs 10 liters of 20% witch's blood and 5 liters of 80% witch's blood to make his desired brew of a 40% witch's blood, 15 liters of 40% witch's blood. So, happy Halloween, and we will see you in class.